All right. I think 2 weeks ago I mentioned that we are working on a solar uh, polarimeter, and just today we finished setting it up. So I'll just show a few things for that. So let me share that. Let's see. Okay, so you should now see my screen, I hope. Yeah, okay. So first, just a few words about the science motivation behind it. So what we are trying to do is to monitor the polarization in the L band, that is at 1400 megahertz, the emission from the sun. So we are just moving a little bit away from the hydrogen line. And the background is that there's not too much known. There's quite some work at different frequency, but we understand there's not too much scientific work on the L-band emission and the polarization. So typically, what you'll find is that you get unpolarized emission from the sun. But what happens during solar burst, it can actually become polarized. So what we are trying to do is to monitor long time and then just capture the solar burst and then look at the polarization. Question is there any polarization, to what degree, and is it linear or circular? So that's what we're trying to do. That's what our setup looks like. There's a cantenna. We always use a stovepipe to construct a cantenna with two probes, which are at 90 degrees to each other. And then we have the no-OLEC LNA with filter, the one which quite a few of you will know. And they have to be fed by a bias T. So we are feeding in 5 volts onto the coax cable. And then from the bias T, we're going on to a two-channel SDR, where we're using the Atos B210 for that purpose, which is spitting out IQ data. And then we are using a PC to collect the IQ data and then do the calculations of the four Stokes parameters. And that will tell us what the polarization is going to be. Now, this is the setup. It's fairly straightforward and simple and easy to make. The only it's not really a challenge, but the only thing that you need to take care is that you actually have a dual channel SDR. So you have two channels which are coherent. So we have been setting that up. This is a view of what the outdoor unit looks like. So we have, yeah, that was originally built for our interferometer L band. We are using essentially the same type of antenna. This is a close-up. You can see that's a simple circular waveguide essentially. There's a lid on it because we are looking up and we don't want the rain to come in. And then there are the two LNAs. These are die-cast housings for the NOLEC, which of course is not designed to be in the open, but with these extra housing that can be put in the outside. And then we have, you just can see a two coax cable running into the inside of this building. And that is just a quick look at the setup there. It's very straightforward. We have the two bias T over here, and then we go on to an Atos B210. We have put our Atos B210 in a 19-inch rack compatible sort of card slot so that we can easily mount that and it's secure. So that's essentially what we have now right now. There's no data yet. We just finished it this evening about sunset. So we're waiting anxiously for tomorrow and see whether we can get the signal from the sun. This is the first step. Do we actually see the signal increase as the sun rises and goes over the horizon for the full day? We should see, that's the experience from our interferometer, we should see the sun for quite a while during the day because it's such a wide opening angle that you have with these antennas. Probably it will be a couple of weeks before we get some data because, yes, there are reasonably frequent bursts right now. There was just a very strong burst a few days ago, and there was a lot of chat about it. But we have to wait for the next one to come and just verify that everything is working. And then hopefully in a couple of weeks, I can show you real data and answer the question, yes, is it polarized or not? And I guess that's all I have for the moment. So if there are any questions, I'm happy to comment.
Wolfgang, what are you expecting? Do you expect polarization just during big events?
Yeah, that's the expectation. So we do not expect any polarization during, let's say, the normal course of things. And the we hope that we do see polarization when we have strong emissions, short-term, short emissions.
Is there a expectation that you need to be up in the M and X range to see any of this stuff, or any kind of flare give you that data?
Well, we know from our interferometer work that we clearly see the stronger flares in L band. Of course, there are some flares which appear only in X-ray or higher up, in even higher up. So not all flares will show in L band, but we've seen quite some correlation during the interferometer work between solar flares that have been reported in the optical and in the X-ray, and strong correlations to strong increases in the L band. So there should be clearly identifiable. Typically, you have an increase of a factor of 10 or even more in the intensity from the sun during the flares.
Yeah,
Well, sorry, Rich.
go ahead.
Wolfgang, have you characterized the Cantenna's polarization purity?
Yes, we did. What we did is also to vary our software that it actually determines the Stokes parameter correctly. So what we did before we put things outside, we had the antenna in the lab or in a test environment, and we illuminated it with a linear polarized signal, which we then turned, and it was correctly indicating the polarization. And we also did a circular polarized antenna. We took a circular polarized antenna and we verified that it's working correctly.
Great.
Yeah, I was looking at Conrad's profile here while you were saying this, and he's just putting together his solar flare detector, super SIDS. And is that something, if you see a flare and you notify us on the listserv, and Conrad,
Yeah.
if you watch the listserv, you might be able to pick up, check and see if you see the same flare that Wolfgang sees, and then you guys can collaborate.
Okay.
Yeah, I can certainly come up and give a notice when we see a flare.
That'd be great. You guys, that'd be good work. Okay, that it, Wolfgang?
Yeah, that's from my side. Thank you very much.
All right, thank you. Peter.
Yeah, I'm on. Yeah, well, I think Andrew mentioned about EZRA at our European Conference of Amateur Radio Astronomy in September. I'd just like to mention a development from that. We were very fortunate in having Professor Jocelyn Bell Burnell as our keynote speaker. And following her, I gave a short talk on how to catch a pulsar in a small backyard. And that was interesting. It went down okay. We had quite a few people from across Europe that came. Wolfgang, Edward, and Mario, and so it was quite an international day. But we also had a couple of young Croatian students. Now, Croatia is a country in Europe. It's on the northern Mediterranean, opposite Italy, if you know. But they came because they heard that Professor Jocelyn Bell was giving a talk about her discovery of pulsars, and they got interested in it. But anyway, that was in early September. In early October, I had an email from these two Croatian students who'd actually put together a basic pulsar detection system. At the same time, I produced a little handout sheet called a starter for radio astronomy. And they kind of used that. They used a bit of the software that I'd written a long time ago. And they actually collected some pulsar data. And they didn't see much in it. And so they contacted me, and they eventually they sent me the file. It was 65 gigabytes. And I had a look at that. And as some of you know, I've been developing some software to detect pulsars at low levels. And recently I adapted it so that in a pulsar record, you could scan this record and find the best area of scintillation so that you get the strongest signal to noise ratio. So anyway, I had a look at their data, and 90% of it was just RFI. But I found a section right at the very beginning. They'd done a recording for about just under 4 hours. And I found a half-hour section that was relatively clear of RFI. And I chopped that bit out and tried it with my software. And lo and behold, I did find a signal just under 6:1 signal to noise ratio. And in the discussions with them, I've developed this software. It's quite a big package at the moment using the C language. I'm not a software engineer. I'm self-trained at software. And so I've been looking for somebody who could take this software and make it a bit more professional. And they've agreed that they've got somebody who could probably do this. So I might be releasing my software. It does a complete analysis of pulsar data. It takes binary files, and it takes data from, well, if you use GNU radio, you can produce data for it. And it produces it. What I've attempted to do is to duplicate the Presto analysis. They've never published the details of the algorithms they use in Presto, so I've had to dream them up myself. And I think I've kind of improved it for amateurs in that I've added this feature where you can take your data, you can fold all the data in a standard method, in the standard way, and produce a result. But also you can scan the data, you can vary the window size and scan across the data and find the best scintillation area, and find out the result of this. So going to EZRA 25 was very useful for me. It's the first time I've had a feedback from giving a talk. I've given a few talks in EZRA. It's the first time I've had his feedback, and it looks like the collaboration is going to work out quite well. Hopefully, if they can get their C expert to go through my software and ruggedize it, then there might be an alternative to Presto and Diaspera and the other professional software packages. So that's about it. Thank you.
Peter, a quick question. What kind of setup were they using to collect the data? So what kind of antenna?
They actually, with Wolfgang, within the month, I was very impressed with them. They built a 3D reflector antenna. They got themselves a standard RTL 2832 SDR. Where they got their amplifiers from, I don't know. But they made this thing portable and they took it out in the field and to do their measurements. So really, it's a copy of probably what Andrea Delimagine did in the early days.
So it was a corner cube antenna then?
Yeah.
Okay.
A 3D corner cube. And they actually built it within this month. The EZRA present conference was about the 5th and 6th of September. And the data file they sent me was dated the 3rd of October. So within 4 weeks, these guys had put together a whole radio telescope. Fantastic. I would present their results, but I'm hoping to persuade them to write a paper for Sarah and get it published here.
Okay. Any more questions for Peter? And if you guys didn't see listserv, Mario Natali has produced a new version of Murmur, which is a very good way to track for pulsars and all the pulsar information. So if you haven't downloaded Murmur, I would recommend it. Okay. Thanks, Peter. Let's go with Dimitri.
Hello to all. Thanks, Rich. Today I have some summary of my work with evolved stars observations this year. Some presentations. A short summary of preliminary summary, I think, of my work this year of observation of evolved stars in main lines. First motivations of this work was hunting for lines, hydroxyl lines 60, 65, 60, 67 megahertz, which are weaker than the magnetic lines 60 and 12 megahertz. These stars includes in my work and my consideration includes red supergiants, yellow hypergiants, evolved star in asymptotic giant branch stars. You can see this in Hertzsprung-Russell diagrams of luminosity of versus temperature, surface temperature of the stars. These stars can emit dominant 16-12 megahertz lines, but also can emit 60-65, 60-67 megahertz lines. And it's very interesting. Not every star has this main lines, but hunting for them was my first motivations of this work. Dominating spectrum of 60-12 megahertz is two-peak spectrum. Two-peak spectrum pumping from infrared radiations from stars and hot dust around it. Main lines usually weak, but much depends of envelope star envelope state. Characteristics of the envelope state includes mass loss rate. Also, I introduce indicator mass loss rate to squared radius because of because of I include in my considerations stars which can differs in mass sufficiently significantly different mass like red supergiant, yellow hypergiant, and usual AGB stars. This indicator shows how dense and powerful stellar with flow is from is in this stage of star evolution. Real through the envelope density can be connected to the indicator if you know stellar wind velocity and indicator can approximately characterize the envelope density in assumption that velocity, stellar wind velocity, do not significantly change from star to star. You can compare the star if roughly compare star characteristic by this indicator. But this is better indicated when masses of stars is mass for star differ significantly. Variability, about variability. Main lines 60-67 and 60-65 megahertz is, I think, is more sensitive tracer of star state and state of star and its envelope because it indicates subtle details of hydroxyl excitations in envelope. Example is clear. Good example is IRS 1704 minus 4190 stars. I observed when historically it has 1667 megahertz two peak lines besides 1612 megahertz line. I have not detected 6067 megahertz line recently, and only say 1612 megahertz line. This reflect this is a good example of variability of the star, and that main lines is more sensitive when you're exploring evolved star variability. Observation instrument green bank 20-meter dish with L-band receiver calibration by Cygnus 8 was made and telescope characteristic was calculated from calibration. List of observed star this year for now 7 stars includes Canis Majoris, red supergiant, HB stars with moderate masses, one yellow hypergiant star, two stars already in late AGB and even post AGB stage, and the beginning of forming protoplanetary nebula around this dying star. They are characterized by sometimes happened super winds and very high mass loss rate and indicator density indicator. This is seven star in the list for now. Fresh observations from last time, two stars, IRS 182276 minus 1431. It's dominating line 6012 megahertz. You see the results for its dominating line up to 30 Yansky in peak. Line 1665 megahertz not detected, but 6067 megahertz line polarized emissions. Magnetic fields by Zeeman splitting is not too high. You can see results of measurements. 6067 megahertz lines in two linear polarizations. They are really different in redshifted peak from 7 Yansky to 12 Yansky. Also, I observed blue shifted peak. I suspect this can be RFI, but and this looks very narrow. But they're different in levels too. I have not removed blue shifted lines from results. It can be from the stars. Next, areas 9244 plus 1115 yellow hypergiant star observed in all three lines. Dominating line 6012. For all lines, minimal peak flood density about 1 Yansky. And you can see 6065 megahertz line up to 6 Yansky and 6067 megahertz line up to 5 Yansky. Shape of 6067 megahertz line replicate the shape of dominating 1612 megahertz line. I am finishing two evolved stars, new to evolved stars are observed. Both have main lines, and I have detected them. One of yellow hypergiant star, its 6067 megahertz line replicates the shape of dominating 1612 megahertz line, and other observed stars RS 18276 minus 1431 gives evidences of polarized emission in 60-67 megahertz line. This is all for now. If some questions, I will be glad.
Oh, good stuff. We got any questions for Dmitry? Oh, great. Now Dmitry obviously likes the big telescopes. So if anybody wants to, as a member of SARA, you can use that same telescope. Just hook up with Tom Zikas, and he'll hook you up with an account. Okay, does somebody have a question? All right. Thanks, Dmitry. Good work.
Thank you.
Okay. Edward.
Hello, hello. Can you hear me?
Yes.
Great. So, yeah, I don't really have anything new to show today. I am working on some things. So, yeah, I've made a new video for the channel on detection of the thermal radiation of the moon at 10 gigahertz with a small telescope. So that's new. I'm also working again on detecting the Andromeda galaxy at 1420 megahertz. It's something I've already done last year, but what I'm trying to do this year is that I'm trying to do drift scans at different declinations. And I hope to build a sort of map of the Andromeda galaxy because yeah, despite the fact that it is like around the same size as the beam of a 3-meter dish, it's around 4 degrees in extent. You can actually see differences depending in the spectrum, depending on where you're pointing. And this was also already done before by I believe Jean-Jacques Mentoux. He also did a mapping of M31 with a 3.3 meter dish. So I know it's something that's possible, but he was using a tracking mount, and I'm going to try this just using only drift scans. However, I have some trouble with the system stability at the moment. So one of the great challenges with M31 is that it's a weak spectrum and it's extremely wide. It's spread out over like 2.5 megahertz or something. So you need a very stable system. Otherwise, if you have any distortion in the in your background curve, in your base your bandpass curve, it's extremely difficult to remove that with dark subtraction. So that's a bit of a challenge. I think what's going on is that we have some strong out of band RFI that's somehow becoming a problem. So we have some very strong RFI here over at between 1450 and 1470 megahertz. So maybe that's what's causing some issues. So yeah, other than that, well, that's it for now at least. Yeah. Any questions, remarks?
All right.
Hi. It's Mark here. Sorry, I had a question to Edward.
Yeah.
I didn't actually watch carefully, but I heard your lunar observation. I was working in the allotment and I switched it on, and I noticed you were using an equatorial mount. Is that right?
Yes.
Yeah. Is it necessary?
For the moon? No, because essentially I was just doing a drift scan, but I have put this small dish on an equatorial mount. Firstly, for convenience, it's just very easy to point it that way at different points in the sky. And I already had the equatorial mount, so yeah, I might as well just use it. And the second reason is that I'm also doing other observations that do require tracking with the same mount. But you can, in principle, just do this observation of the moon just fine, only in drift scan mode.
Right. Okay. And another question. with your 3-meter dish, I watched your video on that, setting it up and taking it down. You would never be able to put that on a tracking mount, is that right? It's too big.
It's possible, but you just need a very heavy mount for it. These are expensive pieces of gear, so I don't have one. And yeah, I mean, at 1420 megahertz, you can still get away with doing drift scans. I mean, like the beam width is 5 degrees. So if you're pointing at the celestial equator, yeah, you're going to get about 20 minutes of useful integration time during a drift scan every day. And if you're pointing like further north at higher declinations, of course, it's going to take longer. So you can collect for somewhat more time.
Okay. All right. Thank you very much. Thanks.
All right. Any more questions for Edward? Edward, make sure you put down your YouTube channel, a link in the chat for everybody. We want to make you a millionaire doing radio astronomy. That might be a first.
I don't think so.
YouTube stars all say that until they become one. So, okay, thanks. Mark, why don't you go next? You're
All right. Yeah. Sorry, I've not got much to contribute except I'm working on some kind of mount to put the Noelec dish in a low noise environment, low RFI environment. And in parallel, I was under the misapprehension that with the very low frequency observations for the sun, the book I was reading, I had the impression, where is it gone? This one. Can you guys see that? Yeah. I think it's quite famous. That I would be able to run solar flare observations from home because they wouldn't be prone to so much RFI like the hydrogen line. And then I read somewhere else it's not true. They would be prone to RFI. So I don't know. Anyhow, today I bought this thing. Oh, can you see that? It's a magnetic loop antenna. I was going to look into purchasing the supersid from that Sarah advertised, but the customs, I mean, the shipping charges of $60, and I bought this whole thing for the same price. Yeah, so I'm going to attempt looking at solar flares whilst I'm setting up this the Noelec dish for hydrogen line. Yeah, I just had a question about this LMR 400 cable that we use for the hydrogen line. Is that sort of weatherproof? Can you leave that outside? Is it robust against rain and cold? Does anyone know?
Well, if I recall correctly, LM, you said 400 is somewhat similar to what I know as AirCell 7. So it typically would be suited for outside use. I mean, we use this type of cable all the time on the outside. So,
I mean, I wouldn't leave it outside permanently, but if it got rained upon for a day or 2 days, it's not going to ruin it, is it?
No, it will not. So I mean, we keep our cable sections, some of our telescopes. They have been out in the wild for 2 years or more. So
okay,
in any weather. So that's you should be doing okay. Of course, over a long time they might deteriorate a bit, but not too much.
Yeah, I'm afraid that's all I've got to say, guys. Sorry.
all right. Thanks, Mark.
Okay.
Do we have any more non-U.S. Members online?
Can I ask Mark where his who's the author of that book he was holding up?
Oh, yeah. Steve Arnold, I think. Can you see that?
Yeah, but I can't see the author's name. I think it's at the top.
Sorry.
It's okay. Thank you. Thank
You're
you.
welcome. Okay.
Okay, go ahead, Harm.
Okay, I haven't prepared any presentation, but I could tell a few things about the activities currently at the Dwingelo Radio Telescope. Well, something quite special. We participated in a concert of a classical piece of music on Friday. The concert was taking place in Freiburg in Germany. And what we did is we streamed the signal of a particular pulsar, to be precise, B0329+34, which is the loudest pulsar in the sky. Streamed that live to the concert hall, and it was used in a sort of percussion concert. I wasn't present, but I read about this. Seems to have been quite a success. Then about 2 weeks ago, or 3 weeks, no, probably 3 weeks ago, we had in the Netherlands, we had the Night of the Dark Skies, which is the weekend that we switch from summertime or daylight savings time to wintertime back. And then we always have the telescope open for the public and give demonstration, which was quite a success. I think we had about 120 visitors on that evening. We also had a few optical telescopes at the radio telescope, and between rain showers we were able to see quite a few deep sky objects. Another thing that we were doing, we had a grammar school student observing several pulsars. The student pupil has to make a science project for her final exam, and she visited the telescope for getting sufficient data to work on that project and make a presentation. And last Thursday, we had about 30 students from a university in the northern part of the country, the University of Groningen, doing pulsar observations, which they also usually then work out at the university. And one of the things that we're quite active at the moment is with helping a Japanese institute, I think it's called the Riemann-SAT project, to track down what is wrong with their small satellite called RSP-03. It was kicked out of the International Space Station in late September, and since then it has hardly been heard, and it's only partially responds to commands from the ground station in Japan. And what we then usually do, we track the satellite and gather as much data as we can and send it to Japan for analysis over there. They have not been able to fix the problem. It seems that the antennas haven't deployed correctly. And I'm not sure what they can do about that, but okay, that's their problem. And I think I'll leave it at that. For next time, I'll make another overview.
Excellent.
Okay.
Any questions for Harm? Can you go ahead and put the link to your site,
Yeah.
your antenna system?
I
That's
will.
All right. Any more non-U.S. members online that haven't talked yet? Okay. Any U.S. members who have a presentation?
I don't have a presentation. I just have a piece of information that I found yesterday that I thought the Sarah members might be a little interested in.
Go for it, Monroe.
Okay, let me share this. And there we go. Okay. Something I just stumbled upon when I was doing some research on the cosmic microwave background was that the Netherlands, in conjunction with China, has a radio telescope in a figure-8 orbit about L2 that is low frequency. So if you know the Netherlands, they're into low frequency radio observations, and they have this thing called NCLE that kind of ride shared aboard the Chinese relay satellite that they use for communicating with their rover on the far side of the moon. So I, added that in my presentation I did last night for Broad Astronomy, because I was doing something on what is the lowest frequency of the cosmic microwave background, and stumbled upon this thing and went, "Oh, that's interesting." And once you start looking for something, you can follow the rabbit hole. And I found that that's actually a presentation from a university in Colorado in the US. So a number of groups are sort of tapped into watching this thing and what it's going to do. They haven't produced a scientific result report out yet. They're still doing observations, but they get down into the 80 kilohertz range. And if you're pointed away from the sun, away from the earth, away from the moon, and you're that far out, you're going to be able to observe things that cannot be observed in low frequency from on Earth, because the Earth's atmosphere won't allow you to transfer through it, or in Earth orbit, because there's too much RFI noise coming up from the Earth, or even in high orbit of the Earth, you get too much. And since the Earth rotates, you're sometimes going to be pointed at the sun, which is a low frequency, high emission source. So by putting this out at L2 and facing away from the Earth, Moon, Sun system, I think they're going to come away with some observations that have not been previously possible. So it's something to watch. Let's see if I can reload that. So that's what the satellite looks like, and you see the three monopole antennas in a configuration that allows them to get a slight view of direction and potentially phase. And you can see there it's 80 kilohertz to 80 megahertz. So well below what we think of as the cosmic microwave background at this point. Let's see, this one is, some of the technology is not just from the Netherlands. Some of the communications technology they're using is from South Africa, and they're also known for some low frequency radio astronomy. So it's, NCLE is, I'll put this in the chat. So if anybody's interested, you can start your digging into the rabbit hole for NCLE. And that's all I had.
To add to that, I participated in that project during its infancy stages.
Cool. It's one of those 6 degrees of freedom kind of thing.
Yeah, indeed. We were then at that stage we were just sitting with our feet on the table and trying to find out what the communication budget would be. By the way, it's more difficult to get data from China to the Netherlands for analysis than from the moon to China.
Yeah, when I stumbled upon it, I found a little tidbit from the Netherlands, and I started looking around at other sources. And yeah, if you want to tap into the actual data flow, that's inside China, because it's their satellite that they're communicating with. So until they publicly release some information, you're just waiting. And the last report I saw out was in 2023, and they were saying the same sort of thing: is data has been received, the data is being analyzed, but we have nothing to report at this time. So, okay.
Yeah. And I think that not all 3 antennas deployed fully.
Yes, yes. They're supposed to be 5 meters long, and I think one of the antennas went out to like 2.5 meters.
Yeah, exactly. And, and even still, they're still receiving quite useful data. So well, it's quite an achievement.
Yeah, and the fact that they're going to be able to receive at lower frequencies than any other thing that's ever been put out there, and they have a really radio quiet area pointed away from the sun, Earth, Moon system. So it'll be interesting to see if they come away with a conclusion like the CMB actually is, well below 300 megahertz. Um, just interesting to keep an eye out for them.
Certainly, yeah.
And I can add one more thing I heard was that there was an effort to not transmit around the moon below 2 gigahertz by man-made stuff. There are some missions that were started prior to that designation, so there's some people still transmitting, but there's an effort to not spoil the astronomy aspects of the moon.
Yeah, they're up at the gigahertz level for the communication from the satellite back to Earth. So I don't think they're disturbing that aspect of it. So if you look, there have been projects to put radio telescopes on the far side of the moon. So yeah, you don't want to despoil the low frequency areas. And they're not transmitting, they're only receiving. Unless you count the spurious emissions from electronic sources inside of satellites. Okay.
Okay. Thanks, Monroe. Conrad, you had a question. Conrad Cardano?
Let's try that again.
All right, there you go.
All right, thank you. I've been sending my SuperSID data to Stanford, and that's worked out really well. So I thought it was time to move on to a new project, and that had to do with detecting meteors in the ionosphere. And I've gone through every YouTube video there is on the subject, and I've gone through the EZRA website, and I've put requests out on the Google groups, and I've got a lot of good information and help from that. And I have SDR Sharp and SDR console installed, and I'm expecting a dipole antenna to arrive tomorrow. But the one thing I can't get information on, because I'm not a ham radio operator, are all the settings that I should be using for either SDR Sharp or SDR console to try and detect meteors in the ionosphere. It is very confusing because it seems like there's a lot of settings on there. And I wish there was a book, Radio Astronomy for Dummies, because that would probably be really helpful to me. And so if anybody has a suggestion in that area, I would really appreciate it. Rather than have me just go through and test a lot of things and maybe just, accomplish nothing in the process. Anybody have suggestions?
All right. Well, from my understanding is the meteor detection is you're receiving the bounce off the ionosphere off the trail of the meteor.
Right.
And that bounce has to be associated with approximately 55 megahertz from some kind of a transmitting station on the ground, just out of your sight. And as soon as the meteor shows up, it actually now you can see it and you see the blip. Ted, you guys got that at the Little Thompson Observatory. Well, I don't know what kind of receiver you're using there, but it might be what he's looking for.
Yeah, I think I know a guy who knows a guy, and so we're going to get back to you, Conrad.
Thank you very much. Yeah, the settings for the Sharp or the SDR Sharp or SDR console, those settings would be very helpful. because when I see things like the bandwidth or the sampling rate, I don't know which the right ones to use
Right.
because
We're
there's a
using
lot
SDR
there.
sharp. So we'll get back to you, but I don't speak with authority. We'll
Okay.
find out.
Okay, that's really helpful. And thank you very, very much. I've put questions out there, and the people in Sarah have been very helpful. I just want you all to know how grateful I am.
Great. Great.
Now,
All
I'm
right.
curious, if you want to receive signals, from what transmitter are you receiving the signals then? I mean, there are
Oh,
no analog television transmitters anymore, and that's what we used to use in the past. But what are you
my
using? What are you using?
understanding
Yeah.
is there's one in Canada in the 55 megahertz range.
Well, we're
Okay.
successfully using digital transmitters for TV, and that's working fine.
Oh, okay.
So
Okay.
at 52 megahertz.
Okay, that's good too.
In Belgium, there are two transmitters specifically for this purpose, and they transmit at around 50 megahertz.
We can get away with this channel 2 method because we don't have a channel 2 in our area. So anytime we hear channel 2, it's being reflected off that meteor up above.
Okay.
Conrad, I'll be back to you.
All right, thank you, Ted. I
All right.
appreciate it.
Okay. Ted, well, now while I got you on, anything else going on?
So I'm the guy that working on with this EZRA software, it seems. Where I've been working for maybe 3 months now on all kinds of ways to try to come up with support for other SDRs than the RTL SDR that we're familiar with. I started off with GNU radio, and I finally think I've determined that it's not very efficient. So, but we're having success with SOAPy drivers talking to AirSpy and SDR Play, both the RSP2, which is old, and the RSP Duo. So that looks promising. And then this morning's test was on an EDIS B210, which apparently got recognized. So I think there's hope here for other receivers. I'm not quite ready to post it, mostly because somehow I installed it. How was it that I did that? So we got to figure that out and document. And in the meantime, on the analysis side, if we have these new receivers with a real big bandwidth, is it appropriate to uh, compare the signal from the sky, which I call the antenna signal, to a reference in the same sample? So you're not, uh, Ezra's method was to collect a reference sample at some frequency and then an antenna sample at the desired frequency and compare those. So is this more efficient, or is it just require more luck that you don't have RFI? So we're studying that. And then, of course, in the future, I'm trying to figure out how to worry about drift scans of external galaxies and how to have that displayed properly in EasyGal conveniently. And then my big dream is to have a wrap around the data collection program that also knows how to control motor mounts and even electronic motor mounts like Rich is trying to come up with phase shifting. So anyway, that's the news on the Ezra front. All vaporware at the moment, but we're making progress.
All right. Thanks, Ted. And the aforementioned phase shifting project that I was doing, I had two phase shifters, but I determined that they were the data, the signal is extremely distorted, and they're not distorted the same way with two separate phase shifters. And what comes in is not what comes out, even with zero phase shifting. So I've abandoned that phase shifter as an approach to doing a phased array antenna. So I'm going to shift to something else. I haven't figured out what to do it yet.
So Rich, even if they corrupt the signal, do they do different serial number phase shifters corrupt it the same way?
I have two phase shifters, and the signal is distorted with zero phase on them. I actually I have a 3 meter dish that I'm using EZRA software on, and it comes out very clean. I hook the output of the 3 meter dish to the phase shifter and then back to the EZRA, totally distorted. And I did it again with the other phase shifter, totally distorted. All right. And no matter what I did with the phase or even combining the phases, it's just the signal is just lousy. I don't know what it's doing inside. It's a digital phase shifter, so it's an 8 bits, and you can change about 1.4 degrees phase shift depending on what the digital input you have. But even with zero phase shifting, the signals, it's horrible. So I'm not sure why it's doing that, but I know that my antenna is good because I could see it on the software without the phase shifters in between. But when you put a phase shifter in between, it's horrible data. So I'm
So can we do
re-looking at that.
experiments? Can we do experiments with a phase shifter called a coax, different lengths?
No, I haven't done that. I tried to use a digital phase shifter that I can control with an Arduino, and the phase shifter itself seems to be what's distorting it. Yeah, now the other way to be doing, I can always phase shift it with changing the chords, but then you couldn't automatically do it. That'd be very cumbersome. But that's potential if I'm just going to do some drift scan, long duration drift scans. That might work. Okay. Let's see who else is online here. Dennis Farr.
Yes, sir. Thank you very much. Just glad to be here. Hope everything is going well. I'm having fun trying to keep up with you. Every time we get a new member, everybody should know this. Every time we get a new member, Rich sends them out a welcome from the president, which is, makes them hopefully feel very welcome. And of course, I have to do the uh, receipt for the payment and one thing. And I don't know if he realizes it, but I consider we're in like a race. I try to beat him with the receipt before he gets to welcome out. So that's my life is just trying to keep up with Rich, and it's been a lot of fun.
I really enjoy you being you're helping there, Dennis. And Dennis, the one who recruited me to be his vice president before COVID. So what comes around, it's that saying there, Dennis. So glad you're helping. Thank you very much.
Oh, you're most I'm just
and
glad.
Tom, just checking in on you. How are you doing?
Good afternoon to everyone. I'm here. I have news, and it's bad news locally. Late last month, the health department came in and did a test on my well, and the well flunked the test. And this morning, I went outside and found 20 gallons of water sitting in my driveway. And I tried to move some of that into the garage. And after moving maybe a third of it, I was just so exhausted I came in and sat down. So I don't have too much else to say. There's still, 40 gallons of water or something like that sitting in the garage in the driveway, and I don't know what this all means. They did have a note to say that we did this. I was happy to know that this was not a misdelivery. Excuse me. But beyond that, I'm surviving. I don't know how well I'm surviving, but at least I'm surviving. And I'll quit with that. Turn it back to you, unless people have questions.
Thanks, Tom. If anybody who lives near Tom, maybe you'd give him a call, see if you can help him with his water issue. Okay. Let's see.
I can actually tell you that no one lives within 250 miles of me who's on the EZRA membership rolls. The closest one is in York, South Carolina, or something like that, which is Charlotte. Charlotte is a 3-hour drive to this side of Charlotte and 4 hours to the other side of Charlotte. So that's not close. I'll get someone to help here locally if I have to, but I might just try to do it slowly. Anyhow, thanks for the thought.
You,
I,
you
I
be
have a
careful.
quick question. I have a quick question just out of interest. What was the health department say what the failure was on your well water?
Yeah, we have a problem with a chemical plant that's 2 hours up the Cape Fear River. And once upon a time, they had a permit that allowed them to discharge PFASs into the Cape Fear River. And apparently now they've decided that this is a forever chemical and it's bad. And so the surviving chemical plant that's up, beyond Fayetteville, North Carolina, almost Lillington, if you know where Lillington is, on the Cape Fear River. It's contaminated. A lot of the river is contaminated. The mud in the river is contaminated because they were doing this for 40 years before anyone realized that there were bad effects to the PFAS. So this is another hot zone for PFAS. The good news is that I stopped drinking the Wilmington water, 30, 40 years ago. Shortly after I moved here, I just decided that it tasted bad. And even when I was drinking my local water off my local well, I ran it through a water softener and a distiller. So I've never really consumed the water for drinking. I use it to wash. So I do wash my dishes in it, laundry and stuff. But I've never really consumed it. Because I thought it tasted bad. Water's not supposed to have a taste. So I'm upset by it. Anyhow, looks like I'm not going to have to be buying bottled water for quite some time. And I don't know what's going to happen long term. Anyhow, back to you, Rich. And I know what I want. Also, you were talking about the 20-meter telescope. It's Stephen, not Tom, who heads that.
Oh, yeah. What am I thinking? Yeah.
Too many Toms. Okay, I'm going to go back
All right.
here to worker mode. I'll talk to you all if you have questions.
Thanks, Tom. All right, Dan Sherrico?
Draco.
Sherrico. Oh, I'm sorry. Thanks.
Draco. That's okay. From Mesa, Arizona. I don't have anything to report. I've been trying to slowly but surely purchase the hardware for the scope in the box. Problem I have right now is that new electric Sawbird LNA. It's not available. And then I thought I found a vendor in China and made a purchase, and they claim it was shipped and delivered to my home, but I never received it, and all their customer support email addresses are inactive. So imagine that. So I'm kind of dead in the water. I can't move forward without purchasing that LNA. Do you have any resources or a vendor that you can reference or refer to me to where I could buy that?
We use Amazon. If it's there, it's there. But that or eBay, I guess, is the two choices. Anybody else got another resource they can find new Alex on?
Not a resource for the new elec, but has anybody tried the discovery feeds for the hydrogen line in place of the feed for the scope in a box kit?
No.
I've had decent results with that off of both that style of grid dish and the discovery dish.
Yeah, I've heard the discovery dish works pretty well, and that does not have a new elec. Is that correct?
That's correct. It's a FR4 circuit board dipole antenna that's a little weirdly constructed to enhance the bandwidth, and there's a filter and an LNA right on the board. So I think they make up for the FR4 losses by not having the coax the way that Scope in a Box does.
Okay. All right, I'll research that.
If you got a link to that, you can put it in the chat.
Yeah,
That'd be great.
I'll drop it there. It's on crowd.
Yeah, I've heard
Thank
good
you.
things about the Discovery dish be able to pick up hydrogen. Let's see. Don Latham. Don, you there? Okay. Preston.
All right. Enjoying the discussions. I really have nothing to add today. Thank you.
All right. Thank you. Bob.
Okay, I'll share something here if I can get the correct screen to come up. So I do operate some Meteor cameras, and there was some discussion about the Meteor, so I just thought I'd bring this to your attention. This is a place you can look at on the web called Global Meteor Network. And if you just do a search for GMN and space status, you'll get this website. And over here on the left, it shows you the active people that have cameras that are watching for meteors in the US. And I have a station here that's in North Texas. It's right here in the middle. I've got 4 cameras active. And so over here on the right, you can see the individual uh, results of each of those cameras. And so like, for instance, one of my cameras is this 4Q camera. And this image on the top is the actual meteors that it saw last night. And they're like just streaks of light here, but then mixed in, you can see the stars that rotated through the view of the camera through the night also. And then down below is a view that includes airplanes. And it looks like there was a meteor here that got dropped out. And this is sorted out by like an AI algorithm that takes airplanes out of the image. And it doesn't do a real good job because there's a few airplanes left. But it also records those in thumbnails. And if you if you get on here and you go down through this, you'll see a lot of other information that's available. But if you're trying to do radio monitoring of meteors, you could use this tool by looking for something that's close by and see what's actually active at various times. By looking at the thumbnails, you can get the actual time of day that the meteor occurred through the night. So you could correlate your radio results with the actual results. Any questions about this?
Yeah. Hi, it's Mark here, Bob. So what kind of setup did you use to take these photos? It's just normal SLR camera pointing up?
It's a inexpensive camera that you can order from China for around $40 US. But there's a very active group in the UK also, Mark, and you can get together with those guys and they'll help you along with the project. But if you go to that website that I mentioned, the Global Meteor Network website, they have details about how to put one of these together. Many people use a Raspberry Pi for the computer to collect data. I'm using
Yeah.
an i5 based computer to run all 4 of my cameras.
Yeah. Okay. Interesting. Thanks, Bob. Thank you.
Mm-hmm. And that's all I have today.
Thank you. Let's see. Wendy.
Hello, am I on?
Yes.
Not much going on here today. Like Tom, I have home things that have come up and are taking all of my attention. I'm just glad it's not 40 gallons of water half in the garage. So but no, nothing much to report.
Okay. Thanks, Wendy. Let's see. Dennis Hoopnickel.
Okay, can you hear that? Can you hear me there?
I get you. Here you go.
Okay, okay. Let me make sure that you can hear me. Yeah, you can hear me now, right?
We hear you
Yeah.
fine.
Okay, good. I'm sorry. I'm too used to having nobody listen to me. Anyway, hey guys, I have nothing to add, but I do enjoy the conversation, and I am interested in a lot of the stuff you're talking about. So please keep it up. Appreciate it.
Thanks. Adrian.
Yeah. Hello. Let's see. Well, I don't have any of my own stuff to present, but I'd like to show something. I don't know if anybody'd be interested in seeing this. Let me see if I can get presentation on. Share. And is that screen coming up?
Yes, we see it.
Yeah. Okay. Well, these aren't local meteors. This is a group. Well, the BAA, the British Astronomical Association, they have an active transmitter that they use specifically for meteor detection, and you can see the some of the returns that they're getting. There's some of the big slashes there, obviously, are airplanes. And so, if anybody's interested in looking at meteors that are coming in over the British sky, they can go to the site. I don't know if you can see the site up there at the top, the ukmeteorbeacon.org/beacon client. And so they've got a running real-time observation from, as you can see, from a number of locations. There from 6 different locations that they have different receivers picking up the reflection off of their active transponder on. I believe it's everybody pretty much uses around the 50 megahertz range. Although the reflections can be observed actually all the way up. I remember the old sky fence that the U.S. used to have across the southern border, and that was up there around 200 megahertz. And of course, they were using a megawatt or 2 transmitter power, and so that gives a pretty good meteor reflections off of there. But obviously, the best reflection is down more around 50 megahertz. So I just thought I'd bring this site up because it's fun to watch and see what some of these returns are. You can see it scrolling there. Some of the returns they're getting, but that was kind of one of the things I wanted to present. And there's some interesting news that I happened to run across the other day, and that is I'm sure you guys have heard of the 3i Atlas, the interstellar comet that's going through our solar system right now. And there was some news that the Meerkat radio telescope down in South Africa actually detected hydroxyl, not emissions. Now, this is interesting. They actually saw the 1665 and 1667 megahertz absorption lines of hydroxyl. So I guess they're looking at the galactic background and seeing the absorption lines from the water emission from the comet as it's going through our solar system and on its way back out into interstellar space. And I'll put the link of that in the chat if anybody's interested in looking at that article. But anyway, that's pretty much what I had to say, and that's kind of it for me.
Great stuff. Is that something we can see? I don't know, Wolfgang. Is that something if you tracked 3i Atlas, you could see the hydroxyl hole there?
Yeah, I heard
Absorption lines,
about
yeah.
that. I heard about that, but I haven't tried it yet. Maybe if we get a chance, we could try to see the absorption line. I need to check on the paper how strong the signal is or how difficult it will be to get. But it may be worthwhile trying, certainly.
That'd be fun. And Adrian, if you go ahead and put that link in the chat, then it'll show up on the YouTube channel.
Sure, I'll do that. See, I'm trying to unshare here and not finding the right button. My apologies there.
I'll use my powers of
Okay, I'd appreciate that. Thanks. It got blocked out on the screen. Yeah, that was from from the Meerkat radio telescope, and so they've got quite a bit of aperture area there. So I'm not sure if even Wolfgang's telescope might be able to pick it up. But hey, might be possible. It'd be something worthwhile to maybe take a peek at and see what that might be. So I've got the link. Let's see. Yeah, it's in the chat now, so you can look at that that paper. Great. Oh,
Thank you very much.
My weird camera there's an IR thermal camera. So if I look kind of strange, it's the only camera I can get to work. My built-in camera on my laptop doesn't work, so I added on this external thermal camera, as you can see there. So,
Adrian, we weren't going to mention it.
I don't see any difference. Yeah.
Everybody has a bad day, so that's okay. All right. Thank you. Robert Mead.
Hi, Rich. Yeah, recently got that welcome email from you. That did make me feel very welcome. I've been following on the YouTube for the past couple of months now, and recently followed up my processing order to get the journal access on the Dropbox. So I was having a good time reading through some of those. I do have some stuff to share today. I'd like to present a few slides on my 5-element solar cooker interferometer that I've been building in my backyard. As soon as I can find the share button, which somebody
bottom center.
Bottom center. One more. I'm not seeing it in bottom center.
Should be a green. Green
yeah,
bottom center. Oh, there you go.
Thank you.
Now you got to go to your window of choice. The window you got your slide set on.
I think you guys can. Are you able to see or?
Looks great. 5-element solar cooker.
All right, sweet. So these are the 5 solar cooker dishes that I've kind of built in the backyard. So to start with kind of where the idea came from here, have been watching your recordings of these meetings for about the last 6 months. And one of the members had an idea to do a 5-element interferometer with the Kraken SDR. I had one of those sitting in a box for a long time that I haven't touched, so this seemed like a good use for that. And another member had proposed using a 1.5 meter solar cooker as a relatively low cost dish. So I was able to get 5 of those off of Amazon for about $80 a pop, and then took his advice on painting those. And then I just needed a feed. So that's we'll see some of that in a little bit. I was kind of looking at the Kraken RF stuff because it seemed like a available feed with an LNA and a filter, so I didn't have to worry about the supply chain for the New Sawbirds. And then kind of the goal with this is to keep the cost material-wise about the same as scope in a box, and then get 5 or so dB of G per T improvement. The theoretical, at least over the Discovery dish, for a 70 centimeter aperture being a 6.6 dB sensitivity increase. And then I'd like to be able to keep the mount that comes with these dishes and try and get some kind of precision sighting system. If I could get 0.5 degree pointing accuracy, I would consider that a win for doing different drift scans, given my main beam is like a 10 degree kind of thing with this size dish. So I did 1 dish first because didn't want to go in on 5 before I knew this would be possible. Bought the dish, assembled it, did the painting, and then tried to work out a 1-inch PVC boom adapter for the 20 millimeter fiberglass boom of the Kraken RF Discovery feed. So this was kind of the first 3 iterations of that 3D printed part design. And I didn't do anything with trying to optimize the placement too much for where the actual focal length of the dish was. Just kind of set it outside and ran SDR Angel, was able to verify detection when the main arm of the Milky Way went over there, that little 7 Kelvin or so spot that it's calling out in the sky plot in the upper right. And we see some stuff with a 1024 point FFT out the hydrogen line there. So this is just a air spy, and then just the Kraken RF discovery feed with the filter LNA built in, and that seemed to work pretty okay. So then I decided to go in on 5xing that and did some more iterations on that feed design to help with water drainage. So I added some holes in the bottom there, tried to make it more easy to 3D print so I didn't have to do support material, and came out with 5 of those plus the adapters. And then I wanted to add laser sights to them. So I've added a little laser sight mount there. And then it's pretty easy to align those sights by using a laser bore sighter, replacing the feed temporarily. I guess we'll go in this order. So I just took the feeds off, put a laser bore sighter on there, put the laser on my mount to then kind of line them up real quick. Of course, remembering all of your relevant local laws, rules, etc., for responsible astronomy laser use. So the photo on the left is kind of what I did with the bigger dishes, but in an example for a discovery dish. And on the right is kind of a rough alignment of all 5 of the dishes. In this case, pointing into the constellation Lyra. And then this is the data acquisition unit. So I took the Kraken RF, put it in a kind of waterproof box, added some cable glands. And then I was trying not to have a Raspberry Pi out at the remote. So this is a USB to Ethernet converter. And then the Ethernet just runs all the way back into the house, about a 100-foot run. And then you can plug USB into whatever computer on the other end. So I can bring full x86 horsepower connected to grid power. I don't have to deal with a Raspberry Pi being the DAC out there. And then, so this is just a quick look at the initial array geometry I built in the backyard. The photo on the first slide is not how I have them. Saw the presentation a couple weeks ago about kind of optimizing where they would be placed in the UV plane, and that all seemed very interesting, but realizing that I'm going to have to calibrate exactly where these are in UV space by backing it out from observations. I wanted to just start somewhere that was a little bit easier maybe to back out, but still put some effort into sizing my longest baseline and avoiding ambiguities between different interferometer legs. So I have the green and the orange circles on my 2 L-shaped legs are not the same distance from the other 2 points on that leg, and then the longest baseline was sized to get about a degree of angular resolution. And I have some notes on here. Just there is a possibility to do rotational and frequency synthesis with this setup, but it's going to be pretty limited because I'm using the fixed ASL mounts, just doing drift scans with what came with them. So I can't track for like 12 hours and do a whole lot of rotational synthesis. And then this was first light off the 5-element array. So just there is a there. This is 2.4 megasamples a second, and then roughly a 5-minute averaging time. As I found out, the sample rate of the Kraken is not controllable in GNU radio. So even if you set it there, you have to go change it in the Heimdall DAC for the coherent samples to get to actually change. So all the labels on these graphs are suspect, but very much there's stuff there. And of course, I need to do plenty of calibration to get these nice and flat and work through the differences in the filters and amplifiers between dish feeds. So that's all my slides. I'm hoping this is interesting to folks here, and looking forward to maybe bringing some Skyscan data in the next couple of months.
That's exciting. That's fun stuff.
All right. Any more questions for Robert? Did you get any interferometry out of this when you had more than one?
Not yet. This was just single dish processing. I have been saving the raw IQ and working to minimize the storage space requirements. I think I can get down to about half of what the other person on here suggested, because we should only need 4-bit IQ for this task. Looked into compressibility a little bit. Wasn't super compressible, even if you do principal component analysis, because I don't want to throw away any data. So it's going to be 4-bit Packer. And then, I was really hoping to use EZRA with this, but I couldn't find a way to work directly with IQ input I was able to adapt the DISPRA GNU radio spectrometer flow graph and look at single channel in EZRA that way. But I'm hoping that there's an impetus there to, in support of interferometers, take recorded IQ files as input to EZRA.
So if we brought in an IQ file, how would we actually compare two antennas is my concern. I usually work with intensity, or maybe frequency. So that's my first question. Back to Rich.
Well, yeah, Ted, you can't take in his 5 antennas separately and just run 5 instances of EZRA, I guess, and then combine them. I don't know how that worked, but
I have to think a lot about this.
I do have a question back to my my phased array thing I'm trying to do. Does the Kraken software allow you to do delays between antenna inputs?
Yes. So the Kraken DAC is a driver that controls the FPGAs in the Kraken SDR itself and does some kind of noise injection and self correlations to align all the channels in time and phase. Then when they come out of that GNU radio block, you have time and phase aligned samples, obviously with whatever shifts are from the cables and antennas themselves on the actual inputs of the system. But after that point, if you wanted to do completely digital beamforming, you can do any or all of that in GNU radio. So for narrow bandwidth,
software supports that, or is that really you have to do your own software?
That's really you got to roll your own there. But the ChatGPT has been very helpful with helping me to write GNU radio blocks, especially like the 4-bit IQ packer. So,
all right, I may have a new option here. Okay, hey, excellent work. You keep coming on and showing us your stuff. All right. Let's see. Tom Hagen.
Hey, I'm really enjoying the all the presentations today. These are quite impressive and quite inspiring too. On the other thing I've been spending some time with is EZRA. I loaded up and I really enjoy it. I think it's a wonderful program. Thank you, Ted.
Any insight into that LOFAR program?
Or what was that?
The LOFAR?
Oh, low phasm.
Low phasm. I'm sorry.
Yeah,
low phasm.
Yeah. I've been working with a couple of students at Fairmount State University in West Virginia. Marcus Fisher referred me to them, and we're working on a new data browser so that we can, attempt to see, review the data somehow or another. It's still pretty preliminary, but thank you, Rich, for funding this effort for the next year.
All right. Okay. Thanks, Tom. Thomas Oglesby.
Yes, hello. Can you hear me all right?
Yep.
Hey, so I just joined Zara a few days ago. I've been watching the YouTube videos for quite a while, learning radio astronomy. I actually made a 2.7 meter dish and was able to get the hydrogen line. But I actually had joined the group to kind of share the observatory project that I was starting. I had made a post about it in the Google group, but I'm starting like an initiative to try to buy a big 10-meter radio telescope that I found on Facebook Marketplace of all places, and it was on top of a really nice looking positioner, and I started it's called the Titan Observatory, and we got it all. We're pretty organized right now. We just are in the process of fundraising for it. But the goal for it is to turn it into kind of a public observatory to allow pretty much anyone to use it. We have a site picked out to move it to, and we've been kind of working the numbers, and it looks like it's going to be pretty reasonable to be able to acquire this thing. So there's more details like in that post, and there's also, I think we also have a website. I can put that in the chat as well.
Okay. Wait, keep us informed on that. Let's see, Bruce.
Yes. Hello. Yeah. Okay. I'm in here. I see the lit up green. Okay. Yeah. A couple of things. First, this last week I did a presentation on, using the IBT to actually watch some solar eclipse and lunar eclipse things in the past. Did a presentation for the local astronomy club. That went real well this time. September 3rd. Yeah. September, I was supposed to do a presentation, and well, 3 people showed up and went ahead through it anyway, just a practice run. October, I had to pick up my daughter at the airport. So November, I finally got around to actually doing it. And actually, I had a good group of people there and good questions. And one blunder I made on that is I forgot to bring along a cheat sheet with all of the EZRA website information to give to any people. And there were a few young people there that I should have, handed a sheet to, because I mentioned that they can get grants from EZRA, but there's nothing like giving them a sheet of paper with the address. So anyway, kind of bombed it on that one. So we'll see next month. I'll let people know where they can find stuff. So that's for that. The other thing is about 2 months ago, Dick Flagg was on here with us, and I was talking about noise from Zener diodes. And Dick took a big interest in that. As a matter of fact, after I did a little, 3 minutes of talk here, got an email from Dick saying, "Hey, would you like to kind of basically take over the project he's got of making a noise calibrator?" So I guess now it's my project and Dick's project at this point. But from that, I've been exploring Zener diodes as noise sources, and I've got some interesting things on that. Dick originally used a Zener diode down around 6 volts, which I found some advice online advising that. And 6 volt Zeners turns up are very sensitive to noise output versus temperature. If you go to 8 to 12 volt Zeners, they have almost no sensitivity to, you warm up the diode and nothing changes, so to speak. So I have discovered that much. And, I'm looking at the range because it was basically for Radio Jove, it would be from 10 megahertz to 200 megahertz range we'd be looking at. So although Zeners can put out above that, that was the area I was looking at. And got a bunch of different brands of 8.2 and 12 volt Zeners, and have started characterizing them. So that's a endless task. And these Zeners are in little bitty SOT23 packages, which means I haven't burned any of them out, but I've probably lost about a dozen of them on the floor of my workshop now. So they're a little devilish to work with, small. But anyway, I'm continuing on with this project, and one of the things that's interesting is that below about 30 megahertz, there seems to be a sudden rise in level of noise coming out of these Zeners. And it's real variable from Zener to Zener. Some of them are almost flat down to 10 megahertz, and others will have a 10 or 15 dB rise there. So that's something to be sorted out. Other than that, if you go from 30 to 200 megahertz, all the different brands and samples I've tried have been about the same. I mean, within reason. But that low frequency, which of course would be part of Radio Jove, seems to need some individual calibration. So that's basically what I'm running with. Things I've run into that when you start running current through a Zener diode and watching the noise, you start at a very low current and nothing happens. And then above some threshold, it starts suddenly producing noise. And then as the current goes up, the noise goes down and stabilizes, which I wasn't quite expecting. I was thinking, oh, current goes up, noise goes up. No, that is definitely not true in low frequency region. So anyway, I'm making lots of discoveries about Zeners, and I've already started writing the paper for the EZRA journal, which is probably a few months away because I've got a lot of experimental work to do yet. So that's kind of where I am with I guess the Dick Flagg project that was inherited. I'm not sure. I wish he was here today so I could comment on that. But anyway, that's about where I am, and that's about it for here.
All right. Any questions for Bruce? By the way, Dick Flagg, who was really big in the radio Jove, is always on the Drake's Lounge Australia, which I'm going to pitch again. Is Drake's Lounge Australia is this Melbourne time? It's on Saturday at 9 a.m. UTC. It's Friday at 2200 UTC. So and Dick's always on there. He's in Hawaii, and I think it's just a good time zone for him or something. But if you guys want to hear him talk, okay. Thanks, Bruce. Carl Spillman. I think you're last, Carl.
Afternoon, Rich. Thanks again. Great talk today. Just a couple of updates. I guess I'm in the same situation as Dan, waiting for that Sawbird filter to show up with the scope in the box. So in the interim, what I've had my students doing is we've constructed just basic antenna, a simple dipole, just to hook it up to one of the CB radios that we have, just to kind of introduce them to, what antennas are all about, how they function. And I guess next project will just be build a ground plane antenna for the same CB radio, just again to kind of show them the basic concepts that they're dealing with. And eventually we'll get all the parts for the scope in the box, and we'll have that constructed. It'll have a presentation, some pictures to kind of show. One question, I guess, just about the links that go into the chat. When are they available? Once we're finished here, how can I access those links that everybody's putting up?
If you go to the YouTube and you go, there's a little description on it below the YouTube video, and you hit the more on there.
Okay.
I've got all of the chat and all the links on every YouTube videos below there.
Oh, great. Okay. Excellent.
And plus a AI generated time for who's presenting and stuff. So that's if you guys haven't looked at that, all the links have always been in there for the last couple of years. I think people just have a hard time finding it.
And if you can't wait, you can save it right now. You go to the chat window. There are three dots at the top right for me anyway, and one is save chat. It puts it in something like Documents, Zoom, and then like a description of whatever meeting we're in today.
Oh, right. Yeah. I see.
Good luck.
Makes it easier. Good. All right. Thanks again. Great meeting today.
Thank you.
I have a question for Carl.
Sure.
Why are you using a CB radio?
Well, that's the only thing that we had laying around in the classroom, and I guess this goes to Rich. It's a warning to everybody. Once you join SARA, you end up taking your technician and your general test for amateur radio, and that becomes a whole nother great endeavor. So thanks again for that part of it. But that's what we had laying around, so we figured let's see if we could hook it up and see what we get.
Well, why not introduce them to software defined radios? These little SDR dongles are so cheap. I mean, like $30 or $40 will get you one of those, and you can introduce them with a laptop, and you can start introducing the kids to sort of the more modern radios, which are what everyone is using.
That's a great idea, because along with the scope in the box, the parts that I've gotten so far, I did get the SDR component. So you know what, that's going to be my little project for next week. I've got that set up available. So great, thanks. That's a great approach to it as well.
Yeah, well, you can hook that up with SDR Sharp or one of the other softwares and look at all the other frequencies that are available. I mean, if nothing else, you might have, for example, your local NOAA weather radio up around 160 megahertz. That might be something interesting to listen to. I mean, with the current sort of weather changes that are going on across the continent now. And so that might be a little bit more instructive than your CB radio, and just listen to the CB chatter. But I don't know. I just thought that would be a good way to maybe introduce them into the function, and that'll be a head start for when you get your full system up, and then you'll already be familiar with the SDR radio and some of the software and whatnot that you can use for it, and get started with that. Anyway, just a suggestion. That's all I wanted to bring in.
Great advice. I'm going to take a look at that once we get back to school next week. Thank you.
All right, thanks, Carl. Go ahead.
How's your school funding these days? I know that in the past, when my son was in school, teachers were it was such a big deal for them to get a hold of any money at all.
Yeah, quite a bit. We still go through those issues. I have to thank Sarah for the scope in the box donation. That was a big step. So we look for grants and donations from business partners and things. It's a challenge. Nothing's cheap anymore with school. It's just everything's expensive.
All right, glad we can help. One other thing is my sister-in-law is a teacher too, and she's currently doing the Python segment in Khan Academy. And so I'm helping them out a little bit. And that's a really good, you guys, Python seems to be the radio astronomy software of choice. I think Ted's, all of Ted's stuff's in Python. And this Khan Academy really walks you through from start to finish to get up to speed on Python. So I'd recommend that. I think it's free, or a small donation or something. But khanacademy.org is look up the Python course.
Great. You guys, you're going to keep me from retiring with all these great ideas I've got now. Thanks again. Appreciate it.
Nobody in this group retires. They just work for free.
Yeah.
All right. That's the equivalent of being retired. Okay. Anybody else that I missed? Okay, thanks very much. And the next is Drake's Lounge Australia on this Friday, Saturday nomination. Okay. Thank you, everybody.